Sorry, it's almost uh, just a bit.
Uh,
Okay,
I
so
see live on YouTube. On YouTube, yeah,
yeah, and
I can check it.
you can start.
Yeah, okay, thank you. Hello to everyone. My name is Krishko Bogdan, and we are going to start our Physics for Development section of our conference. Um, Today, our speaker is Ajit Kumar from International Union of Pure and Applied Physics. Um, Okay, so Ajit working at Inter-University Acceleration Center in New Delhi since 1987 and obtained of Master of Science and PhD in Nuclear Physics from University of Calcutta and Master of Science in Particle Acceleration Physics from University of Manitoba, Canada. Um, he working mainly of design and development particle acceleration and association experimental facilities. Um, for the past several years, he has been leading a project for developing low-cost equipment for teaching science and using open source software and hardware tools. Um, the details of the product which they developed are kept in public domain. It's a conception of open source projects. Um, I think that Ajit can tell about this.
Okay, thank you, Krish. So should I start now then? Hello.
Yeah, absolutely, you can start.
Okay, so share screen should work from here, right? I can.
Yeah, yeah.
Yeah, okay.
You
So,
can share screen and choose your presentation.
is it visible?
Yeah, yeah.
Okay. Good afternoon, everybody. I'm Ajit, and I'm presenting this on behalf of the Commission 13 of IUPAP, that is Physics for Development. And so first I'll start with the activities of Commission 13 and then go a little bit into the scientific equipment and the open instruments. So mainly C13 promotes the scientific research activities in developing countries, one by supporting international conferences. And it's also involved in processes to provide experimental facilities, mainly like synchrotron radiation light sources and other things. And past couple of years, we have been dwelling on promoting affordable scientific instruments, and there is a small working group inside Commission 13 focusing on that. And myself, I joined actually C13 3 years back, so I would probably focus on the new activities and rather than the history of the earlier activities. So the first thing is the support for the conferences. So every year, Commission 13 supports something like 3 conferences, and the applications are accepted only from developing countries. And the job of the committee is mainly go through all these applications and select 2 or 3 of them based on their scientific merit. And each conference commission supports something like up to 7 to 8,000 euros each. So that is one activity. And another major activity is the light source for the Africa, Americas, Asia, Middle East. So under this project, at the moment, there is no facility set up in Africa, but there are programs to support students to go to different synchrotron facilities all over the world. And this project gives them some support. And this is a joint program of UPAP and International Union of Crystallography and funded by International Science Council. And also there is a project going on to set up a synchrotron facility, and that is a collaboration between the LAMP project and African Light Source Foundation, and that is progressing. And this is just a brief summary of the LAMP accomplishments so far. So they have made some strategic plan for all these areas, and then conducted colloquium on crystallography, and also some brochures are made in different languages for publicity. And another major project is this FAST. So send these faculty students team, so from developing countries to various facilities all over the world. And this project, the LAM project, gives the financial support, something close to something like 2,000 euros per month, something like that. So they select students and that. And then actually they are assisted in establishing extract lab in Benin for training crystallography and related subjects. So this is kind of summary of the LAM activities. And these are these 13 members. It was actually last week we had a meeting, and this was a screenshot of the 2 members missing. This camera was not. And this is Kazia chairman. And this is Francois. He was actually supposed to come today, and when the invitation came, he was not well at that time. So that's how I happen to be here. And these are the other members. And inside C13, we have a couple of working groups. So one is on affordable scientific equipment. Again, Francois is the chair. And there is another commission, a small working group on women in physics. So I am basically inside this working group. And mostly I've been focusing on this area. I mean, past something like 20 years, I've been doing something on this. So I'll just move on to that. And now if you come back, okay, in general, the global scenario, because since I'm from India, you can see both here. You will find developed areas, and also you'll find underdeveloped or developing areas. Both are actually kind of coexisting in India. So in some way, we have some sort of first-hand information here. And what we find, most of the developing countries face problems in science education and research. In fact, I'm working in an institute that was established somewhere in 89. So I started in 85, and we established a particle accelerator facility, a 16 million volt pelletron, for the university in India. And that was the first time the universities in India was getting a particle accelerator. So we started operating in 89, and then later on expanded the machine. So, I mean, what I'm trying to tell you is the facility was not that common like in the developed world. And that is about big facilities, but now coming to the smaller facilities for teaching and other things. So if you look at it, the resources available, like the MOOC, the different courses. So basically to learn theory or doing some research in theory, it is possible. I mean, something of the information on the net and all helps. And there are open access journals and other things. But when it comes to experiments, we require scientific instruments. Equipment is required. And they are really not affordable. And one reason probably is you can say the weak currency. Most of the developing countries, the currency is weak. So things, whatever you have to import, that becomes expensive. So what we see is there any solution to this? And people are already attempting different solutions, and we'll just talk about that. So one good thing happened is, like past maybe couple of decades, is the fast development of consumer electronics items. Even though they were initially supposed to say even the personal computers, the growth was happening in the 80s, and it was driven by most of the time hobbies or people who are into gaming and all. But whatever happened, the output benefited the research community also. If I give one example, here in the beginning we imported to microvax computers, and they're fairly expensive in our currency. And we were running that for nuclear physics experiments, data acquisition systems were running on microvax. But later on, when the PCs came, that time it was 80486, and the Linux operating system became available, we could replace them with these PCs running Linux with much better performance. So that was a kind of benefit which we got from the proliferation of the personal computers. And now, if you look at the components, like if the smartphone industry and many other things, there are a lot of sensor elements. If you take even a smartphone, it has accelerometer and many other optical sensors, everything. So all these components have become much cheaper because of the mass manufacturing of these devices. Same with the control elements. So sensor and control elements have become much cheaper. Laser sources are available. And they are also all actually the side effect of these consumer electronics, you can say. Another major development is microcontrollers and single board computers like Raspberry Pi. Of course, smartphone. And special mention is the 3D printing technology that has made the prototyping much cheaper and faster. So now all these put together, like when you have the components to make a scientific equipment, the next thing what is required is the know-how. And that is where the open source philosophy comes into the picture. And basically, I am personally a strong believer of open source thing. I came across that somewhere in 94 about the free software movement. And that helped me implementing a lot of systems here, particle accelerator control and data acquisition systems. And ultimately, based on that, developed something that will that is now, I mean, becoming somewhat popular, the small lab equipment. So here, actually, this what I stress is the philosophy, like whatever knowledge we freely share, and that's what happened in the free software movement. Then later on came the open hardware movement, and this is one major component of the Arduino. And okay, this I put here because it is mine, I would say. I mean, it's not that popular like the other two. And another one major development is the KiCad, electronics design and automation software. Because whatever we have been doing with very expensive software like OrCAD and many other things, and now we do it with KiCad, and KiCad now is supported by CERN. And this has been a major development. They say like whatever the C compiler did for open source software, this KiCad does it for hardware, because sharing hardware designs now become much easier. So that means, to summarize, the building blocks and the shared know-how, that opens up a possibility of making affordable scientific equipment. So at least you have something to start with. And these are certain examples, and basically all this given by Francois to me. He has been collecting a lot of information and working on it. So this is some example with, you can see the links are here, the sources where it comes, like a lot of science experiments are now based on smartphones. So that saves a lot of money and it is affordable to people. And making lab equipment, again, using these components that is available. It's again just linked to some projects. It's a centrifuge. And then the 3D printer is another project from Africa. So it's all, the bottom line is the cost is very low. And another one, the microbalance, is also an open source thing. And the pepper sensors from the Harvard, this lab. And we also have that fold scope, the microscope, that $1 microscope and such developments. And of course, this is the one which I have been doing for a while. And this, you can find the details here. And maybe I can just switch to another place to show that. So here you can see it is, a transistor is here, and an experiment which require a lot of other things, we just do it here. So we have these, you can connect it to a normal PC, or you just connect it to even a Raspberry Pi is good enough. Like like this, you connect it to Raspberry Pi, does the same thing. So this one project which we started, and it is going on, and it's not only electronics, we do a lot of experiments in mechanics, sound, like velocity of sound, and also magnetism, like electromagnetic induction. So you can see here, there is a pendulum sitting here, and the time period we measure with something like 100 microsecond accuracy, just using a LED and a phototransistor. And a microcontroller sitting this will do precise time measurements. So actually this can measure within a sub-microsecond, but because of the other sensors, the diffraction and other things, reduces it to something like this, 0.1 millisecond. So now I'll just touch upon something which is recently I have been doing, and find probably in the present situation it is something relevant. Because like in all other places in India also, this education, the classroom teaching has been disrupted. And immediately people have been trying mostly the video conferencing tools to run the classes wherever network coverage is there. I mean, India, everywhere it is not there, but at least the cities, the coverage is very good. And the feedback is something like this. If you just use these video conferencing tools for classroom teaching, what we are trying is just trying to mimic the offline, our normal classroom teaching using these tools. But what we find is, we don't know, like even this, suppose somebody is listening to this, what I'm saying, I have no way of getting a feedback, whether people are really getting bored or anything like. So a teacher doesn't get a instant feedback, and it has a high, bandwidth requirement is also high. And one thing I noticed, people always ask for a recorded session. That means they are more comfortable probably going through that offline, outside the classroom hours. And there is no evaluation, other things like a proper teaching, that all evaluation, assignment, all those things are not available. So here a learning management system is far better than this stopgap solution probably. And a proper LMS will give you the features to share the resources, and also you can have forums, chats, and others evaluation tools like quizzes and assignments and everything. So that means the advantage is the learning process spreads outside the class timings also. I'm talking about, see, already this is done by the sites like Coursera, edX and all, but I'm talking about the same thing done by, that can be done by a small school in the, for its own students. So for that one, fortunately, we have the Moodle learning management system, and the advantage is Moodle is open source, and it has excellent documentation and community support. Actually, when I started somewhere in April exploring this, so within a couple of weeks, I could establish servers and start training teachers. The documentation was really good, and things were working fine. And it has a large user base, something like 22 million users, what they have documented. So here we have been running one for training some teachers, now another one, and C13 also we are considering setting up an LMS, again, just to train teachers from developing countries. So to conclude, what I just want to say is, we know that science, the philosophy of science is free sharing of knowledge, and technology, it is the other way. Like normally technology is to make money, so it's patents and all the norm, protecting the know-how. But if you can have technology development following the philosophy of science, it could probably solve the problem of development, supporting development using technology in the developing world. So that is one option. And the free and open source software and open hardware, probably they are the key components of it. And science education and research could be a suitable starting point, because if you want to get these equipments in the other areas like healthcare, a lot of checks and balances has to be there, certifications and everything. And these probably the governments, universities, and NGOs can take a lead in such things. And that is what, I mean, the kind of perception I have. I cannot say I'm an expert in this, but that's a kind of feeling that I have, and working in this field for a while. And now I can just show some of the things. One is the important, let's say, GNU operating system. This started in '83, and this KiCad now supported by CERN. And of course, these open access journals, important, and the Raspberry Pi, and this I already showed. And you see this, like the COVID, a lot of activities making these sort of things. And people could do because Arduino is there, so many people do many things like this. So something, some know-how in the open domain was very useful. So that is probably all I have to say. Maybe we can just discuss things and
Yeah, thank you for presentation. It's really interesting, and so we can go to the question. Um, what are the main challenges of the work of Commission 13 and efforts for development in general?
okay, C13, as I told you, C13's role, if you say, I mean, like one is I told you this supporting this conferences, and also that's it's, I mean, the scope is not that wide if you look at it. C13's role, and another area has been this. So the challenges means, okay, what we presently what we face is what I observe is we need to build up a network, a direct network with these educators, teachers and researchers, to implement some programs on the ground. So at the moment, we do not have a very direct link. So that actually, having a negative effect on
Mhm.
our working at the moment.
Okay, how has your work and that of Commission 13 adapted to the station of pandemic situation?
Can you repeat?
um, how your work and Commission 13 work adapted to the COVID-19 situation in world.
Okay, COVID-19. Okay, in the meetings we just had a review of. I mean, just discussed what is happening at different places, and what we thought is in this scenario, probably the practical side, what we can do is try to do something which help the teaching that has been disrupted already. And there is a proposal now to set up a learning management system under C13, and probably try to train teachers so that they can, you know, at least overcome these effects of this disruption due to COVID-19.
Uh,
So that
okay, but during a pandemic, yes, all world stay home and start communicating online. And during this period, you increase your progress of education, health education.
Mhm.
Yeah.
Right, yeah. So I know what is the question actually, right?
Okay. How do you address the lack of economical means, infrastructure, and technological resource in many countries or regions?
Okay, that there is no single probably answer. There are many ways, and probably one key is the cooperation, because resources, even developing countries have resources, but what is really lacking is the know-how. See, if you take in the case of India, okay, in some part of it you can consider as a developing world only, but here also the talent is there, resources are there. Most of the time, what is lacking is the know-how, the technology. And what I guess is most of the, maybe if you take Africa or South America also, if you can have the technology, the know-how somehow available, then with the available resources and their human resource, problems can be solved. But here, because we have practical example here itself, because when I started my career here, at that time that was before the internet era. So to do anything, the information how to proceed, that was very difficult to get. And that has become better, but in some areas, the know-how is blocked. People, I mean, when it is having a financial implication, it is not shared. So that is where probably the big labs and maybe some of even the corporates can, I mean, we are talking about, like, suppose say some of the things, big industries where people, suppose if you take a defense industry, there nobody will share anything. But when it comes to healthcare or education, if some technology is open, that will make a big difference. Say like water desalination or sanitization, all those things. There are technologies available, but not really accessible to everyone. So this is one key point, because resources and human resource both are, I mean, material and human resources are actually available in developing countries as well. But the know-how is probably lacking, and that's what I feel.
What is the relevance of international cooperation in advancing science and technology across the world, but particularly in developing these areas in the regions that have less economical means to invest in them?
Yeah, that there actually that collaboration cutting across the national boundaries is very important. That if you see even national boundaries, and it is not that hard. For example, if you take in developing countries also, some part of them, and some people believe that knowledge has to be shared, and some don't. I mean, some are not advocating that, but there are a lot of people in developing countries, a lot of organizations, and they believe that technology has to be shared. So it is very important that the international collaboration is always, I mean, kept alive. And recently, actually, some places the political developments hamper it, or that kind of things one has to overcome. Actually, that is one of the major hurdles. Suppose because of the political conflicts, the collaboration becomes a little bit, like get affected. Like even recent, for example, like all the raw materials, everything comes much easier from China, but now things have slowed down because of other reasons. And ultimately, who suffers is the people who are in the bottommost level without having any facilities. So anything affecting our international collaboration, movement of material or knowledge, and that has to be given top priority to, I mean, to solve the problems. And I would say it may even help even the developing world sometimes trained manpower that is available from the developing countries, right?
Could you talk a bit detail about free software movement and its importance in democratizing access to technological software resources?
Okay, free software movement, if you ask me, I can probably give some of my personal experience or whatever here. I mean, as some example, like in India, say we started somewhere in 90s, the computers was gradually reaching. I will just take, for example, in the case of education. And the free software movement played a major role in some pockets in India, and some places it has not had any effect. So one example is how can make a difference is if you search for something called on the net IT at school. If you search IT at school project, you will find there is one small state, southern state of India called Kerala. That state in 2000 started a program to have computers and computer education in all the schools. So large project initially started with the proprietary software, but the financial implications very high and unaffordable because every Windows license and Office license, it was adding up to a very huge amount and upgradation. So finally, in 2005, they decided to switch to free software, and now that project is now the biggest free software deployment in the world in the field of education. So if you like, I can just share a screen. Should I?
Mm.
So here, this is their website now. So
Mhm.
this started, and it has been a case study in many places. And the kind of savings that made was it's quite high. So that is just one example, and even in our because I work in a particle accelerator lab, and some of our problems here, like as I told you, the setting up experimental facilities, high-speed data acquisition, and even the machine control, everything we could do in a much better manner, in a cost-effective manner, using very small amount of resources because of the availability of a software. Otherwise, it would have been 10 times more costly for us. Because, for example, our machine is a Pelletron and a superconducting linear accelerator, something like a couple of thousand signals, and it runs on a Linux network. And it hardly costs anything compared to the cost of the machine. So that kind of similar implications are there in many fields, like even making small medical equipment or anything. This free software is a key.
Okay, I saw on your website you have Python course. Yeah.
Yes, yeah. Python is something. Actually, I focus on three things. One is the science experiments using this device, and this whole software is written actually in Python. And we have collaborated. Actually, that software is now available in different languages, 4 or 5 Indian languages, and French and Spanish. And if you see the XPI's website, you'll it's a part of Ubuntu repository, because we have one collaborator from France. He's a teacher in a school there, and he's a Debian developer. So like Python is a key, so we conduct some Python programs, and Python also helps in improving our teaching of mathematics and physics. So I mean, put a lot of effort on in learning, Python and spreading it to teach students. And it has one more implication, like students who are doing physics and mathematics courses, if they learn Python through that, if they are becoming good at it, and after the course, I mean, the job opportunities, that front also Python helps, because there is a demand for a good Python programmer.
For example, Silab Gear, no, your project is also written on Python, yeah?
Yeah, everything is Python, yeah.
You use MicroPython, yes, for
Oh, no, no, no,
which
no.
no?
Okay, it's not MicroPython. What I do for that project is that box. Actually, this is the latest box. It's a small, very small one, and that contains actually a microcontroller. This box contains a microcontroller, and it's that code is written in C. And whatever on the PC side, so they communicate over the USB line, and all the real-time measurements with the sub-microsecond resolution, data collection, everything the microcontroller does, and the data analysis and visualization, the plotting, graphs, everything done by Python. So major code is on Python, but whatever the real-time activities is done on the other end by a microcontroller, that code is in C. And that design somehow works very well, and because it's highly portable, you can run it on any platform, whether Windows, Raspberry Pi, Linux, anywhere, or Mac also it runs. So that is the kind of approach we have taken to develop that thing. And it's on GitHub actually. If you just see Xpice on GitHub, the code is there. And we could get some students also interested in that. And one, I would say, my son also, after his MSc, he got into this PhD in this, making some nuclear instruments, I mean, lab equipment and all. And inspiration was actually this project. And we have few other students also, engineering students, finally, after their studies, they moved into open source projects and all. So
Okay, you said that Moodle helps you to for theory education, yes, but could it help for any practical lesson? Could you add quiz or something, the test system here?
what is
Could you add to Moodle any test system for practice?
Oh yeah. Actually, Moodle actually in somewhere in April I started, and within a couple of months, I set up a server and trained a batch of students. I mean, from Indian universities. I mean, it's not students, teachers, around 40, 50 teachers. They came and started making their own courses, so that practicing. And now we are planning to go in slightly bigger way again, as I told you in Kerala. That's actually, I'm from Kerala, it's my home state. So they are planning on a larger scale, around something like 5,000 schools they want to set it up. So we are now actually planning, and I'm at the moment I'm heavily involved in that, training teachers how to set up Moodle server and how to make courses in an effective manner. Actually, what has happened is they started learning with the sites like Moodle Cloud, Genomia, and all, and now they are trying to implement it. They find it difficult because things were not done in proper way. I mean, like you can make a Moodle course which is a couple of 100 MB, then it becomes difficult to host it. One has to make it small and give the links to resources in YouTube or other servers. So it has to be manageable. So now we are just trying to conduct classes how to make it viable. Suppose if you have a small server in the school, so you have to do it in a manner so that it doesn't demand too much resources. And so that work is going on, and probably it will make a big impact. That's what I hope, because it will help students to access material in outside classroom hours and to interact much better, probably. So that is one thing which we are focusing on now.
Okay. You mentioned that you use 3D printer technology. Yes, and you develop it for yourself. Yes, you develop 3D printers, and there you collect you it. Yeah, you don't buy it, you collect it, or which way you get 3D printer details.
Which one? Which one? The
Yeah. Um,
could you just? I just missed it.
okay. You mentioned that you use 3D printers, yes, for making some details.
Okay, 3D printing. You mean?
Yeah, 3D
Okay,
printing.
3D. Okay,
And
3D.
yeah, you can say.
Uh, okay, 3D printers now, there are a lot of places. If I give a drawing, I can easily, because a lot of people are offering that services here now. Some Fab Labs and or Makerspace and a lot of other places. So you just give a design, and they charge maybe something like $10, $20. Suppose say this box, I got it. I mean, this is acrylic, but the same thing we got 3D printed for something like $20, and it's quite fast. Otherwise, we have to see. This one has a plastic mold, you can see, and to make that plastic mold, we have to make that mold first, dye, and that costs something like at least $2,000, and it takes something like a few months to get it done. So here with 3D printing, within a day, you can just finish your prototype. So the other approach is good for production, but not prototyping. So that facilities are there now. Even 3D printing machines are becoming cheaper.
So you connect with Fab Labs, yeah? You don't
Yes.
design your own 3D printer.
Oh no, here so a lot of places it is there already now.
Uh, okay. Does IUPAP and the Commission 13 in particular reach out to governments and organizations in an effort to push for the implementation of policies that can contribute to development, especially in education and scientific research?
Yes, now the last meeting we are putting some proposal to IUPAP Council in this line. Actually, one is we already set up a small repository collecting the development from all over the world, which is in the open hardware, the scientific instruments. So that you can say only we are just sort of organizing it so that others can use it. It's only pointers, not our development. And also we are planning, we have put up a proposal to set up a Moodle server and probably try to train teachers, and that way we will also the the objective is we may have a network of teachers in our direct contact, so we can probably take up other projects also using that network. So this sort of LMS training acts as a starting point. So that's the kind of intention. So we have started in that direction, put up a proposal. So and hopefully it will materialize.
How did you decide to get involved in Commission 13?
Oh, okay. That's I'll explain. See, the commission members, they are, that see that in all the IPAP commissions, members are the nations actually. So India is a member. There is no individual in that. So the every country has some academy. So India also has Indian Science Academy, a couple of academies. So they decide to nominate somebody to these commissions. Representing India. So something 2017, this Science Academy, Indian Science Academy, they asked me whether I can be a member of that. And the reason for that, I have been doing a lot of work propaganda about this science experiments and Python. So that they were aware of that. And on that basis, they asked me to, you know, just become a member when representing in India. So that's how I happen to be in Commission 13. And it's a 3 years membership. So maybe I'll continue or not. I do not know. That decided by the academy probably. But activities will continue anyway. Informally, I'll be working with them. But the membership, but that is secondary anyway.
Okay, is there any way for students to get involved in the work of the Commission or at least follow its development?
Okay, at the moment, as I mentioned earlier, we do not have a direct link, but this proposal which we have put up now, if that materializes, the plan is what I proposed is like we will offer this training to teachers from developing countries, and that can be extended to students, and even students from anywhere can become actually the trainers, the resource persons, because all these commissions totally IUPAP has only one person, one paid employee, and all are volunteers, all the officials, everybody are volunteers. So here in this project also, if we can get students as volunteers, they become the part of the group, and then at that point we can take up something that will probably benefit both the students as well as the teachers. So it has to evolve once probably we have a network of people and have a close communication, and the possibilities may emerge at that point depending upon what are the requirements and all. Hard to say, what which area we should, because this learning management system, this COVID pandemic only triggered us into that. So things are happening like that.
Is there any, oh no, what advice or message would you give to students that don't have the proper means or access to important resources in their studies?
Okay, I would say, I mean, keep on working with whatever facilities available, and uh, then finally, I mean, it will work out. So if you ask me, even my case, I'm from a small town, or you can say even a small village, and in 70s you don't have technology or anything, but with whatever available, you just learn and try to, you know, reach out to whatever other facilities available anywhere. But the present world, it is much easier because of the communication facilities are there. So I would say try to do the best with available facilities, and try to reach out to people that help actually wherever these forums are there. I mean, like, people, there are people who are willing to help, so we have to reach them to get the network, right? So and I would say situation is far better compared to maybe 30-35 years back when I started, you know, I was a student. So situation is far better now.
Okay, thank you for your answers. Yeah, it's really interesting
Thank
discussion.
you. Thank you very much, and it has been my
You
pleasure
too.
to, yeah, it's a very happy thing. So thank you. Bye.
Bye.